Modern society demands more energy than ever before. It is so critical that semiconducting technology keep up with these growing demands. Trailblazing research groups like ours are beginning to rigorously synthesize novel solid-state semiconductors by combining two anions, say oxygen and sulfur, into one compound. By mixing these anions, these materials can be environmentally stable, and their physical properties can be tuned according to societal needs. Many ceramic solids are what we know as oxides, or metal oxides, and then there are also metal sulfides, so that would be a metal with a sulfur instead of a metal with an oxygen. And so this project is interesting because we're trying to combine the oxygen and the sulfur with the metal in making new materials called metal oxysulfides. We can even do it with selenium, and then we would be making metal oxyselenides. And so by mixing these elements together, the oxygen and the sulfur, the oxygen and the selenium, we can make new semiconducting materials and use them in energy-saving applications. We've discovered a need to combine semiconducting behavior with stability, and this was one way that we could contribute by synthesizing and characterizing the structure of these new materials by mixing these anions together. Many metal sulfides are really great semiconductors on paper. They have a lot of physical properties that are very attractive as semiconductors, but then once they're exposed to water, they break down, right? So oxides are very stable. Metal oxides, I should say, are very stable. So we're trying to combine the best of both worlds. So we're saying, well, let's make metal oxysulfides, and hopefully we can get new semiconductor materials out there that are stable, so that we can use them in more applications, or maybe don't have to be quite so careful with the environment. We can expose them to a little bit more humidity, or a colder or warmer temperature, or whatever is out there in the environment. Mixing anions is a relatively new area. It's really growing at this point. I would say it's an emerging area of research, but scientists in general don't have a set protocol for how to make these materials, and relatively there are very few mixed anion materials. The advantage here is to try to make new semiconducting materials, but also stable semiconducting materials, so that if we use these materials in our applications, in your cell phones, in your solar panels, they have to withstand all of these environmental risks, right? Like rain, humidity, oxygen, acids. So by combining these elements together and making these mixed anion semiconductors, we can have semiconducting capability, so your energy source, but also in a stable manner. So why don't you pull that out? So you want to? I think there are some great students here at UTA to do research that is frontier work that hasn't been done before. I've had students, currently I have a student on my team who was actually in my general chemistry class, right? And she is doing great at this, and we're publishing papers as we speak on this topic. And UTA just has a great environment. The Tier 1 status that we recently achieved here at UTA, I think is a very strong indicator of how we can do this kind of work here and be supported here at UTA.